So this is lesson 4, naming and writing formulas for ionic compounds. In this lesson, we're going to focus on naming ionic compounds using the IUPAC system. And we're also going to look at using the crisscross method to write chemical formulas from the chemical names. So let's start with page 15 in your note packet, where it begins IUPAC naming rules for ionic compounds only. So this lesson's just for ionic compounds. IUPAC is just a universal way of naming compounds. Stands for the International Union of Pure and Applied Chemistry. Compounds have a common name and a chemical name. And there's a systematic method for naming ionic compounds, and we're going to do that during this lesson. So going from the formula to the chemical name, first we have to name the positive element, which is going to be the metal, or a positive polyatomic ion. And then we name the negative element, or a polyatomic ion, second. Replace the ending of the negative element or the nonmetal or the polyatomic ion element with the ending IDE. So fluorine would be fluoride, and oxygen would be oxide. So we kind of take the Y, the GEN out and replace it with the IDE. Here are some examples. Here we have the first one. You name it. So it's sodium, the metal. The second element is a nonmetal, and then we change the ending to chloride. The next one we have potassium. And this is where it comes in handy to know these symbols. Okay, potassium, and then the nonmetal is oxygen, which then gets changed to oxide. Now, next one, the metal is calcium, and the nonmetal is bromine, but we change that to bromide. Aluminum, and try to take a guess. This is sulfur, so that's going to be sulfide. The next one, lithium, is the metal, so we just name it. No special rule there. And then the nonmetal is going to be called iodide. Sounds funny, but it is correct, so you would say iodide. Then, now this is where it gets a little tricky, where we want to go from the chemical name to the formula. We use this crisscross method, but the first thing you have to do is write out the symbols. So we have lithium, and we also have to look at the oxidation numbers, and bromine. Okay, so those are our two elements here. We have the metal and the nonmetal. We look up their oxidation numbers. Lithium is a +1, bromine is a -1. So in order to write the formula, we could do this crisscross method where the superscript number, just the ones, come down here, okay, crisscross to the opposite side, okay, there, to give you the whole formula. But since they are ones, we're going to not write that out. So this is going to be lithium bromide. And there's one atom of each in the compound to make it neutral. Okay, the +1 -1 equals 0. Sodium fluoride, then we have Na, and that's a +1. Fluorine is a -1. And again, since they're ones, we don't really need to do the crisscross method, but I did want to show you how to do it here. But this, they cancel each other out, or they add up to 0, so then we would just write NaF. And make sure that the second element is capitalized, okay? We still have to follow the rules for symbols here. Magnesium chloride. Now this is where you're going to actually use your crisscross method. Magnesium has a +2 oxidation number. Chlorine has a -1 oxidation number. So this 2 is going to come down as a subscript on the chlorine. This 1 would become the subscript on the magnesium, and you would just write MgCl2. We don't write the 1s, okay? But to finish off the crisscross method, we'll bring the 1 down so that you know there's only one atom of magnesium. And then the last example here, potassium. Again, the symbol, okay. So then we have potassium, which has a +1, and iodine, which has a -1. Again, they cancel each other out. So then we would just write potassium iodide. For polyatomic ions, they're named exactly as they are seen on table E. We don't change any endings or anything. So again, the first element is a metal, and it just gets named, okay, whatever metal it is, sodium. Excuse me. And then we look up the polyatomic ion here, and the name of that is hydroxide. Remember, table E is going to help you out a lot with polyatomic ions. First metal here is potassium. And the NO3 is nitrate. Ammonium hydroxide, NH4, OH. So calcium phosphate is Ca3PO42. Now how do I get that? Where do the subscripts come from? Well, the crisscross method. Okay, so before we actually write the formula out, we need to make sure that we have the correct oxidation number. So calcium is a +2, phosphate ion has a -3. When we crisscross these numbers, this 3 comes down here. This 2 comes down here, not on the oxygen, okay? So in order to indicate that, we put parentheses, and then we get this right here, calcium 3 phosphate. All right, so transition metals tend to have more than one oxidation number, so we must use a Roman numeral to indicate their oxidation number within a compound. The Roman numeral appears in parentheses after, and I will capitalize that, that's very important, after the element symbol. This is called the stock system. Okay, so here's an example. Cobalt chloride, and cobalt is a transition metal, could have a formula of CoCl2 or CoCl3, since cobalt can have an oxidation number of a +2 or a +3. So again, if cobalt had a +2 combined with chlorine, remember -1, or cobalt had a +3, chlorine -1, that's where these formulas come from. Okay, crisscross method. This 2 would come down here to give you CoCl2. This 3 would come down on this chlorine to give you cobalt chloride 3. So for this example, if it has a charge of 2, we would write cobalt 2 chloride. And then for this one would be cobalt 3 in Roman numerals, chloride. Let's look at a couple of other ones here. So we have zinc oxide. Look at their oxidation number. Zinc is a +2, oxygen's a -2. +2 minus 2 equals 0. So then we're just going to write zinc oxide for this one. Okay, iron 2 chloride. So here this Roman numeral tells us the charge on iron itself. So it tells us it's a +2, and we know chlorine is a -1. So if we do the crisscross, remember the 2 will come down here, the 1 will go on the iron, and it will be FeCl2. Here's mercury 1 sulfide. Okay, so mercury is going to have a +1 charge, because that is what this tells us here, the charge on the metal ion, or the transition metal. Okay, and then sulfide would just be sulfur, and sulfur has a -2 charge. So then we have to crisscross this. The 2 comes down here. This 1 would come down on the sulfur. and we would write Hg2S. Okay, so in your homework packets, since we're not in class today, on page 5 in your homework packet, let's do a couple together, and then I want you to try to do the rest and be ready to help your group members in class. So here we have 3 elements. We can figure out that there is a polyatomic ion here, and once you get in the habit, you will start noticing or, memorizing which ones are the polyatomic ions. So this is a polyatomic ion. The first element is the metal, and that gets named exactly what it is. So we have potassium, and then we can look this up on table E, and this is hydroxide. So this is just naming. We don't have to write formulas for this practice. The next one over here, potassium, is the first metal. And then we look, remember we have to change the ending to IDE for ionic compounds. So we have chlorine, but it's going to be chloride. The next one, lithium, first metal. And then we have iodide. Iron. Now this is a transition metal. Now we need to figure out if this would be iron 2 or iron 3, because iron can be a +2 or iron could be a +3. So we have to look at the charge on the sulfate ion. Okay, and the sulfate ion has a charge of a -2. So in order for this to balance out, because there's only one iron and one sulfate, then it has to be this one. So we're going to say iron 2 sulfate. The next one, aluminum. Always name the first metal. Okay, that's the easy part. And then we look and we see fluorine, so it's going to be fluoride. Lithium. Bromide. Then we have iron. Okay, that tells me it's a transition metal. You can always double check, okay, to find them on the periodic table. Iron, so now we have to say, we have to do the same thing. Okay, it's either going to be a +2 or a +3. All right, so if it's a +2, then that 2 would come down on the chlorine, and that's exactly what this says, right? Because when we do the crisscross method, chlorine is a -1. The 2 would come down on the chlorine, the 1 would go on the iron. We have FeCl2, so this would be iron 2 chloride. Here we have magnesium, and then again chloride. We don't use Roman numerals unless it is a transition metal. The next one, again we have magnesium. Oxide. Iron. And here's another trick. You can look at the subscript on the metal below it to tell you which one it is, because this 3 would actually come back up and tell me the charge. Okay, you can reverse it to tell you what the charge is. So you have iron 3 chloride. Here, okay, this 2, again, here's your shortcut, would come up. So we're reversing the crisscross method to tell us what the charge is. Cobalt is a transition metal, so this would be cobalt 2, and then nitrate. NO3 is a polyatomic ion, and we look up that name on table E. Okay, NH4NO3. So I have 4 elements here, and this is telling me there's probably going to be 2 polyatomic ions. So I'm going to look this up on table E, and notice NH4 is ammonium. And the next one, NO3, is nitrate. That's all you have to do. Put them together. Let's do 2 more together, and the rest I want you to practice, and we are finished. So we have magnesium, and this is a polyatomic ion called sulfate. And I'm going to remind you, table E. And then we have aluminum. And we have here the OH, again, OH, it's never going to change, hydroxide. You're going to do so many of these that you're just going to actually end up memorizing them without even realizing it, okay? And we are finished.